Okay, lesson 4 is on domain and range. So again, we're continuously reviewing some of the terminology that we've learned thus far in this chapter. So the x-intercept is what? How do I describe the x-intercept?
It's when the line crosses the x-axis.
So it's where the graph intersects the x-axis. And when it intersects the x-axis, which coordinate has a value of 0? The y-coordinate. So then when I'm talking about the y-intercept intersecting the y-axis, which coordinate would be equal to 0? The x. Good. Okay. So now we get into domain and range. From statistics, from math that you've done in junior high, what does range mean? If I ask you to give me a range of numbers, how far something is. So when you were doing statistics and you were finding the mean of a set of numbers, the range would be from the low number to the high number. Well, domain and range mean the same thing, only now we're looking at the graph it represents. And domain refers to the x part of the graph. So the domain is all the possible x values that would make that graph able to be drawn. And the range would be all the possible y values that would allow the graph to be drawn, or that would work in the mapping notation, or that would work in the equation, that would work in the table of values. So the domain of a relation is the set of all possible values that can be used for the input of the independent variable, where the range is the set of all possible values of the output of the independent variable. So we can describe a relation in words, the arrow diagram, table of values, equation, a set of ordered pairs, and a graph. So we're going to be able to determine the domain and the range from each of these different types of forms. So it's not just always looking at a graph that you should be able to figure out what the domain is, or looking at an equation. You should be able to pick any of those 6 and determine the domain and the range. So the way that I remember domain and range, D comes before R, X comes before Y. Domain is X values, range is Y values. I will not give you that information on a quiz. If you ask me on a quiz, what's the domain, I'm going to just, I don't know. If you ask me, is the domain the X values, I'm going to look at you and say, I can't tell you that, because it is an expectation that you know the difference between the domain and the range. So if we look at class example number 1, what would be all the values of the domain in these ordered pairs? Say them louder.
2, 5, 8, 9, 2.
Where's the 2 come in? Domain is which values?
Oh no, that's an x. It's 1,
X.
1, 0, 3, 5.
Okay. So when we list these out, we try to list them out in numerical order. So what's the smallest number?
-3.
And then?
0.
Then?
1, 3, 5.
Okay. Now, in order to show that it's a set, we use a special notation. It's a very technical term. We use squiggly brackets. They're curved brackets. Or not, sorry, they're not curved brackets. They're squiggly brackets. They have that little jut out piece to them. This tells me it's the set of these numbers. So then when I go to write the range, and it's a set, so I use my squiggly brackets, what would the range numbers be in numerical order? 2, 5, 9. Okay. How come the range has less numbers than the domain?
Because there's 2 2s.
Because there's 2 2s, and I don't need to put it in there twice. Okay? And the other thing that you notice is they don't match up to each other. When we're listing the domain, we are listing the set of numbers. So we're not matching input to output. It's not an arrow diagram. It's listing the numbers of the domain. It's listing the numbers of the range. So I would like you to do that for question B, and I'll give you like a minute. Okay, so if I look at B, what is the set of the domain of B? -8.
-8. 0. 2.
Okay. And the range would be what set of numbers? 3 and 9. Okay. So now let's look at the graph. If I look at the domain, try to keep my domains in blue so that when you're looking at it afterwards, it moves. What are my set of possible x values in this one? -4 to +4. So this is where our notations can start to become, this is where our notation can come into factor. And this is the one thing that the workbook does not go through, is the specific types of notation. So with this one, for the domain, I could write down -4, -3, -2, -1, all the way up to +4. That's one way that I could do this. The other way that I could do this, and this is called, actually I'm going to make a new page. So with my domain, that was -4, -3, -2, -1. Okay. This would be a set of numbers. Then what we have is we have something called set notation. When we write set notation, we start off with these squiggly brackets. And then we can say I have the set of x. So the squiggly bracket means set, and then I'm telling you it's an x value. And then I put a straight line. This straight line in math, in this format, stands for such that. Because I don't want to have to write such that, so I use a straight line. Now, the numbers go from -4 to +4. So the way that we can write that is we can say our x numbers have to be greater than or equal to -4. So I read it from x going that way. And then I can put it together to say, or x has to be less than or equal to 4. Now the way that I have it written, is that entirely true that the x has to be -4 to +4? What kind of numbers does x have to be?
The same as or larger than -4, but same as or smaller than +4.
What set of numbers does x have to belong to? Are they whole numbers? Is this a whole number? What is this? An integer. So then, we put one last statement where we say x, and then we use another funny symbol. It looks like an E. And then we would have capital I. So this E here means an element of or belongs to. So when I go to read this, the way that I would read this is the set of x values such that x is greater than or equal to -4, but less than or equal to +4, and x belongs to or is an element of the integer number system. And then that restricts it so that x has to be -4, -3, -2. It can't be -2.5 because I've put this restriction in place. Okay? So I could use either one of those notations to express the domain of this graph. If I was looking at the range of this graph, how would I express the range of the graph? Just as a set of numbers. So 0 to 4. And then if I wanted to use that set notation, this time it would be the set of y values, because we're talking about the domain, such that, and when we're writing this out, so we use this type of format when we have a range of numbers, from a low number to a high number. Low number goes first, high number goes second, and the variable goes in the middle. And then I have my two less than or equal to inequality signs. And again, this time, what set of numbers does 0, 1, 2, 3, and 4 belong to? Whole numbers? They're whole numbers this time. Could I put integers? I could still put integers, because 1, 2, 3, 4 are integers. But I could use whole numbers. Okay? We'll go back. If I look at B, what would the domain of the graph in B, how does it differ from A?
Is connected with the pointer.
The points are connected, so how does that make it different?
You can have numbers in between, but
I could have numbers in between, so I could have -4.5. I could have 1/3. So when we go to express that, we can't use a set anymore. We have to use set notation. Okay? So if I was to write that out as set notation, it would be the set of x values such that x can be between -4 and +4, so -4 to +4. And what number system could x belong to? Real numbers? Real numbers. Not rational numbers. It could be a real number, because pi, which is 3.14, would be right here. I can put pi on a number line. It's not exactly going to be, well, actually I could make a number line where I could say this is 0, this is pi, and this is going to be 2 pi, and this is going to be 3 pi. So I could graph, or I could put pi on a number line. So this would have to be an element of the real number system. Which leads me to one other form of notation. This is called interval notation. Interval notation only works for real numbers. So in interval notation, we put the low number, which was -4, and then we put the high number. And what that means is I'm going from -4 to +4. Then I have to put brackets on either end. And these brackets, again, they have... So with the brackets that I have to put in, I need to put a square bracket. Because this square bracket means includes the value. So positive 4 is included in the domain. Negative 4 is included in the domain. If I didn't want to include it, I would use a curved bracket. So if I had from negative 4 to 5, it means that it does not include the positive 5, but includes everything up to positive 5, such as 4.9 repeating would still be a possible value. So I wouldn't use this for the graph that we were looking at, because that graph does not extend past positive 4. This would be my interval notation. So interval notation only works for real numbers because there's no way of specifying what types of numbers would be in here. So now if I look at my range of numbers, those are my y values. It's the same graph as before, only now my y values could be anything between 0 and 4. So if I wanted to use interval notation, I could write it as I go from 0 to 4, and I can include everything. Now, generally speaking, when we're stating the domain and the range, we use common notation. So if I'm using like a set for domain, I should be in most cases trying to use a set for range. Or if I'm using this set notation, so if I'm using squiggly brackets for one, I really should be putting squiggly brackets for the second one. Okay? I'm just putting both of them on here just so that you guys can see both of them would work. So let's look at C. What is the difference in the graph of C compared to A and B?
They can keep going in each direction.
Keep going in each direction. So what could I have for x values in C? I could have an infinite x value because this is just going to keep extending along the x-axis in the positive direction to the negative direction. So how do I represent an infinite value? I can use the infinity symbol. So I could say I can go to positive infinity or to negative infinity.
And then do you just put your square brackets?
Oh, that was my next question. Is infinity a number? No, because if you count to infinity, what can I do? I can go to infinity plus 1. So infinity is more so a concept. It's the highest number that we can think of counting to plus 1 more. So I wouldn't put a square bracket, I would put a curved bracket. So that's using set notation. Or sorry, not set notation, that was using interval notation. If I wanted to write this as set notation with the squiggly brackets, the way that I would write it is the set of x values such that x is any real number. X is an element of the real number system. As long as it belongs to the real number system, I will be able to find it on my graph. It might take me a while because I might have to extend the graph indefinitely, but I could find it. What about my y values? What can you tell me about my y values?
It can only go to the top.
It'd be forward to infinity.
Forward to which side of infinity? To negative infinity. So if I was to use interval notation,
You have to have a square bracket.
a square bracket around 4. Oh, sorry. 4 is the upper end. So a square bracket on 4, and then negative infinity on the other side. So then one bracket's curved, and one bracket is square. Because it's not confusing enough yet. If I wanted to set this as set notation, I want you to use this. What could I say about my set of y values? What is y always going to be? A real number. What kind of real number? Will y be equal to 5?
No.
Will it be equal to 3? Will it be equal to 7? Will it be equal to negative 10? So what kind of number would y be? Could it be equal to negative 2.5? Or a negative 2 1/3 repeating? Okay? So it could be a real number, but it can't be numbers that are greater than 4. So y, if it can't be greater than 4, it has to be less than 4 or equal to 4. So that's how I could write it in set notation. The set of y values such that y has to be less than or equal to 4, and y is a real number. So the next page has 4 questions that we're looking at domain and range. So we're going to do these one at a time. What I'm going to get you to do first is try to see if you can figure out what it is first. So I'll give you about a minute to do that on your own. And then we'll do them together as a class. Okay? Okay, so let's look at the first one. What are my possible x values? Pardon? It would be infinity both ways, because this is just going to keep getting wider and wider. So I could write that as negative infinity, so domain from negative infinity to positive infinity. Or if I wanted to use the squiggly brackets, because I just like drawing squiggly brackets, it would be the set of x values such that x is a real number. Okay? Unless I tell you a specific method, you can choose between set notation and interval notation. Okay? What's my range? -3 to infinity. So -3 to infinity. And what kind of bracket around -3? A square bracket, because it can include -3. If I was to use set notation, the set of y values such that y is greater than or equal to -3, and then y can be a real number. Okay, so now try B. So what is my domain for B? What are my possible x values for B? Pardon me? -2 and 4, or could it be everything in between -2 and 4? Yeah, because if I was to look at this, if I was to put it on a number line, that's what it would look like on the number line. Because if I follow down from that number line, I'm going to hit the graph every single time. So if I was to do this in interval notation, from -2 to +4, square brackets. Set notation, set of x values such that x is between -2 and 4, and I always have to put in that x is a real number. So with that set notation, you always have to give me the set of numbers that it belongs to. What's my range? So what are my possible y values? -3 to 1. And again, it can be everything, because if I extend out, I'm going to end up hitting the graph at every point. So from -3 to +1. Set notation, the set of y values such that -3 to 1, and again, y is a real number. Okay, so now look at C. The hint I'm going to give you on C is you can't use interval notation. Okay, so let's look at C. What's my domain of C? So in a mapping diagram, what does the domain represent? The inputs. So what are the inputs? 1, 2, 3. It's the set of 1, 2, and 3. So what would my range be? 2 and 6. So I can't use interval notation because they don't belong to the real number system. It's not all the values from 1 to 3, it's just those 3 values. And the last one. A circle with a center at -2 and 3, and that has a radius of 3. So if I imagine this, there's my center, -2 and 3. So the highest point that it's going to reach is when I go up 3 units. What would that point be? If I'm at -2 and 3 and I move up 3 units, where would I be at? -2 and 6. If I move to the right 3 units, where would I be at? No. To the right, this way. So 1 and 3. Okay, so I'm going to give you a moment. I want you to do the next 2. So what would my point be down here and over here? Okay, so what is my point on the bottom? What are the coordinates of this point? Not 6. If I go down 3, I'm at 3. And if I go down 3 units, I'd be at 0. And in the center, if I'm at -2 and 3 and I go over to the left, where would I be at? -5 and 3.
Is it supposed to be like?
So then what will happen is I can join these points to create a circle. So what is the domain of my circle? What are all the possible x values I could have? -5 to 1. So interval notation, -5 to 1. In set notation, the set of x values such that x's from negative. So again, in this one, my domain is the set of values from negative 5 to 1. And then my range would be all the numbers from 0 to positive 6. So in interval notation, square brackets. In set notation, the set of y values such that y is greater than or equal to 0, less than or equal to 6. So that means between 0 and 6. And y is a real number. So in class example number 4, draw the graph of a relation that has a domain where x can be a real number and y has to be greater than or equal to 2, or sorry, not greater than, less than or equal to 2, and it can be any number less than or equal to 2, where there's only one x-intercept. So if x can be a real number, what does that mean on my graph? It's going to encompass the entire horizontal axis, which means that the end of my graph has to be arrows at both ends. Okay? So the only way that I can draw it with an arrow at both ends is if I go like this and draw a straight line. Can I draw a straight line going like that? Why not? Pardon? And what's the second condition? X can be anything, but what about y?
Oh, that would be less than 3.
So if I mark that on my graph, that means that the graph has to occur below this point. So can I have just a straight line?
No, you have the line would have to start at 2 and then go down.
Well, if it starts at 2 and goes down, what am I missing? I'm missing the other half of the graph. So then what do I do to get the other x's?
And you can't go through x twice.
I can't go through the x twice. So what could I do? Well, if I go like that, and I make my arrow go all the way to that end infinitely, is that going to take care of all of my x's to the left? Yeah. Would that take care of all of my x's going to the right? And would that only have one x-intercept? Doesn't have to be a nice graph. It just has to be a graph that shows that the value of y has to be less than 2, and that x could be anything. Okay. Part 2 you might find easier.
Yeah, yeah.
Just draw a quadratic.
See what you come up with. So 2 x-intercepts. Okay, so what kind of graph did you draw for part 2? What did you draw, Colin?
Like, I put the 2 on the same spot as it was on the other one.
Okay.
And then, like, a triangle going up the way with arrows on it.
Like that?
Yeah.
Does that work? Yep. I could have made it go like this. That would have worked. I could get creative, and I could have gone like this. That would have worked, where this point here is going through 2. All of those would have met the 2 conditions. X could be anything because of those arrows, and y has to be less than 2 because that's where I placed it on the graph. Okay. Why is it not possible to draw a graph which has a domain that x could be anything? The range has to be less than or equal to 2, but it can't cross the x-axis.
Because you don't have all the 4 diagonals. You don't have a negative and a negative and a positive.
the right track. It's just
Like,
trying to come up with the words.
Yeah, I just can't think of the words. Like, is it quads?
Pardon?
Like, the 4 squares in the graph.
The 4 quadrants?
Yeah. You can't be in all 4 of them if you just have the, if you can't cross X.
Yeah. If X, or if Y has to be less than or equal to 2, first of all, it means that I have to have all of those. There is no way to get into the negative Y zone without crossing the x-axis. There is no way to stay above from 0 or a little bit over 0 to 2 without crossing the x-axis. So there is no way to have positive and negative y values and not cross the x-axis. Because even if I tried to make it 2 graphs, even if I tried to get cheeky and say, well, I could draw a graph that went like this and stopped there, and then I could do another graph that just went like that, I'm still going to have a hole in the graph right here. I'm going to have a hole where x could be something else. Because in this, x is equal, or sorry, yeah, x could be anything and y is equal to 0. That's where it crosses the x-axis. And I can never be on this line, which means that y would never be equal to 0, which violates this condition. If y is a real number, it has to be able to be equal to 0. Okay, the last question has to do with graphing. A high school football team is hosting a banquet to celebrate the winning championship. The caterer has a setup charge of $500, and then they charge $20 per person. So the equation of C equals 500 plus 20N would represent the cost of hosting the banquet. So we're going to make a table of values for 8 entries with a minimum of 100 people and a maximum of 500 people. So let's see, 200, 300, 400, and then I could fill in the part in between. I could go 150, 250, 450. There's my 8 values. Find out how much it costs for each of those values. So 100 people to 500 people, how much is it going to cost me? Okay, so how much does it cost me for 100 people at the banquet? And 150 people? 3,000? I got 4,500. Or sorry, never mind, I'm looking at the wrong one. So 3,500, 4,500, 5,500, 6,500, 8,500, 9,500, and $10,500 for 500 people. So then if I were to plot these on a grid. So when I go to plot these on a grid, I should be using a ruler, and I should be drawing my my y, and my x-axis. My x-axis will represent the number of people. My y-axis is the cost. So my numbers have to go up to 500 people. So this is nicely split. 100, 200, 300, 400, 500. So this would be the number of people. And then this I need to go up to 10,500. So I picked a scale of 2,500. A scale of 2,500 means each of these would be 500, so it's easy to count. Then I've got 10,000 and 12,500. So now if I plot these points, 100 people, 2,500. 200 people, 4,500. 300 people was 6,500. I know I'm skipping the ones in between. 400 people was 8,500. And 500 people was 10,500. What's the domain? To 500, okay? Is it all of the numbers between 100 to 500? Yes or no?
Yes, it says that.
It's all.
Well, no, it's only the whole number.
Only the whole numbers. So can I use interval notation for that?
No.
No, so I have to use set notation. So this time it's the n values such that n is from 100 to 500, and n is what kind of number? A whole number. What's my range? So it's the cheapest amount I'm going to pay. $2,500 because I have to have 100 people. If I have 101 people, how much is it going to cost me? How much does each additional person cost me? $20. So the next number in my list would have to be 2520. So can I even use this type of notation for that? No, because there's no number system that says it's every 20th value. So in this case, for the range, I would have to list them out. 2,500, 2,520, 2,540, 2,560, and then I can go dot, dot, dot. I have to end up at 10,500, so maybe I put 10,480 before it. And that's enough to establish a pattern that you're counting up by 20s up to 10,500. So why the restriction in the domain is because people are whole numbers. I don't care if you're missing a leg or you're 9 months pregnant, you're one person. That's the way that it goes. The range has restrictions because the cost is $20 per plate. So the increments are going up by $20 each time. So your questions that I would like you to practice with. Question number 1, B, D, and G. 2, 3, B, and D. 4 and 5. And 7 to 11. Ask your question again, Jonathan. Or Brianne asked her question.
Do you connect the dots?
And what was the answer?
Yes.
Why?
Because there's so many dots in between that it's going to form a dot anyways.
Because I tried counting. I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I got 13, and I'm supposed to have 100. So by the time I put 100 dots, it's going to look like a solid line. But we need to understand that it's not actually a solid line. If I was to be able to like zoom in, there would be 100 individual points between those two. It's just when I zoom out, it looks like a solid line.